The battlefield is evolving rapidly, with technologies once deemed science fiction now transitioning from concept to deployment, reshaping global power dynamics in profound and multifaceted ways. In January 2026, several advanced U.S. military weapons systems became fully operational, marking a key shift toward emphasizing technological superiority, adaptability, and resilience in increasingly complex and unpredictable combat environments. These systems prioritize stealth through a combination of reduced radar signatures, advanced infrared suppression techniques, and modular designs that allow for rapid mission-specific reconfiguration, thereby enabling forces to tailor their capabilities precisely to the tactical requirements at hand. New armored vehicles incorporate angular surfaces engineered to deflect detection by enemy sensors, alongside active protection sensors capable of intercepting incoming threats in real time, while reconfigurable hardpoints support varied weaponry, ensuring maximum operational flexibility across diverse combat scenarios. Unmanned combat vehicles emphasize endurance and stealth, featuring sleek, aerodynamically optimized airframes that minimize both acoustic and visual signatures, thus allowing prolonged reconnaissance or strike missions deep within contested zones. Hypersonic missile launchers focus on rapid mobility and concealment, often disguised within conventional vehicles or camouflaged using adaptive coatings that respond dynamically to environmental conditions, making them exceedingly difficult to detect or target preemptively. Internally, these platforms serve as sophisticated mobile command centers equipped with panoramic digital displays and AI-assisted decision tools that analyze vast amounts of battlefield data in real time to recommend optimal courses of action. While their user interfaces are meticulously designed to reduce operator cognitive load by filtering and prioritizing critical information. Significant onboard space is allocated to advanced computing systems, high-capacity energy storage, and secure, jam-resistant communications infrastructure, with a clear preference for autonomy over large crew capacities to minimize human risk and increase operational tempo. Performance leaps across the board include hypersonic missiles capable of exceeding Mach 5 with enhanced maneuverability to evade interception. Drones with loiter times measured in days that can deliver precise munitions on demand. Artillery systems boasting extended range and elevated rates of fire, and naval platforms deploying cutting-edge directed energy weapons specifically designed to counter increasingly sophisticated drone swarms and missile threats. Success across the interconnected land, air, sea, space, and cyber domains depends heavily on rapid decision-making and continuous adaptation in response to evolving threats and opportunities. Comprehensive safety protocols protect operators and minimize unintended escalation, with fail-safe mechanisms enabling autonomous systems to disengage or revert to safe modes automatically if command communication is lost or compromised. Cybersecurity measures are integral and multifaceted, featuring hardened networks resistant to electronic warfare attacks, encrypted communications employing quantum-resistant algorithms, and AI-driven intrusion detection systems that ensure operational integrity and resilience even within heavily contested and degraded environments, thereby maintaining a decisive edge over adversaries seeking to exploit vulnerabilities in the digital battlespace. By 2026, crewed platforms have advanced significantly with reinforced composite armor and energy-absorbing materials that reduce explosion impacts, alongside fire suppression systems using chemical agents and water mist to quickly extinguish flames and minimize damage. Automated damage control systems powered by AI detect breaches, leaks, and fires instantly, enabling faster countermeasures to enhance survivability against missile strikes, drone swarms, and electronic warfare. Operational security relies on layered authorization protocols, including biometric verification, multi-level command approvals, and AI anomaly detection to prevent unauthorized launches, crucial for long-range strategic weapons. U.S. military weapons operate as interconnected nodes within joint and allied combat networks, sharing real-time data and coordinating air, land, sea, space, and cyber operations. Drones designate targets and relay continuous updates, while satellites provide precise targeting data to armored units, artillery, and naval forces, enabling synchronized multi-domain engagements that overwhelm adversaries. Embedded AI continually refines targeting, threat assessment, and resource allocation, without major hardware changes, ensuring systems stay ahead of evolving threats. Modularity allows rapid adaptation through over-the-air software updates and mission-specific payloads, speeding development, cutting costs, and maintaining a technological edge. Despite high initial investments in hypersonic missiles, autonomous vehicles, and directed energy weapons, the DoD prioritizes life cycle value by reducing maintenance, enhancing readiness, extending service life, and lowering manpower via automation. Energy weapons like high-energy lasers and microwaves offer low per-shot costs, near-instant effects, and minimal logistics compared to traditional munitions. The DoD's cost assessments factor in deterrence, efficiency, and sustainability, recognizing that upfront investments prevent costlier conflicts. These systems influence adversary strategies by forcing countermeasure investments and strengthen deterrence through technological superiority, though they raise concerns about escalation, ethics of autonomous lethal systems, and the evolving role of human decision-makers. The U.S. strategic goal remains preventing war by imposing high costs on aggression and creating strategic uncertainty. By 2026, future warfare concepts are fully institutionalized across all military branches, with commanders planning operations using continuous surveillance, fused multi-source intelligence, and near-instant strike capabilities, transforming deterrence and combat. Enemies now face inevitable detection, real-time monitoring, and rapid retaliation, prompting changes in their doctrine, logistics, and morale. With autonomous systems integral to reconnaissance, logistics, and combat, reshaping battlefield character and tempo while setting new standards for effectiveness and survivability. Ground robots now conduct resupply missions under hostile conditions, significantly reducing casualties and enabling units to remain operational for extended periods. Meanwhile, aerial drones autonomously coordinate among themselves by dividing search areas, identifying targets, and preparing strike options without requiring constant human micromanagement. This evolution does not eliminate human involvement, but fundamentally transforms their role. Decision-makers transition from direct control to oversight, validation, and strategic judgment. The rapid pace and scale of these operations grant the United States a decisive advantage, particularly against adversaries still dependent on centralized command structures. Another crucial aspect of future U.S. military weapons, set to materialize by 2026, is endurance. Platforms are engineered to remain deployed longer, function farther from supply hubs, and endure in contested environments where communications and logistics are disrupted. Nuclear-powered submarines with enhanced stealth capabilities can stay submerged for months, carrying next-generation strike options. Long-endurance drones provide persistent surveillance over vast areas, exerting continuous pressure without the political and human costs associated with manned patrols. Even ground systems benefit from hybrid powertrains, advanced energy storage, and predictive maintenance, which reduces downtime. This endurance directly translates into strategic leverage, allowing the U.S. to maintain a presence without provoking escalation. Electronic warfare and information dominance have also become paramount by 2026. New weapon systems are designed from inception to operate effectively in environments saturated with jamming, spoofing, and cyber attacks. Rather than being disabled by electronic interference, these systems adapt, reroute communications, and even exploit enemy emissions to enhance targeting. Artificial intelligence plays a central role by detecting patterns that humans might miss and responding at machine speed, creating a battle space where superiority in algorithms and processing power yields overwhelming advantage, often before any physical confrontation takes place. Despite technological advances, the human element remains crucial. Training for U.S. forces increasingly emphasizes cognitive skills, adaptability, and trust in automated systems. Operators learn to manage complex networks of assets rather than individual platforms, reducing fatigue and improving decision quality, enabling smaller units to achieve effects traditionally reserved for larger formations. Importantly, ethical and legal frameworks are integrated into system design and training, ensuring compliance with international law and rules of engagement even as autonomy grows. This balance between technological prowess and responsible use is a defining feature of U.S. military modernization. Global responses to these advancements are evident. Allies pursue deeper integration to leverage shared data, interoperable systems, and collective deterrence, with joint exercises focusing more on operational scenarios than traditional force-on-force engagements. Adversaries face tough choices, investing massive resources to match U.S. capabilities, developing asymmetric tactics, or risking strategic irrelevance. This dynamic reinforces U.S. leadership while accelerating global military innovation, complicating the security environment, and increasing competition. Often overlooked, logistics undergoes a quiet revolution as well. Predictive analytics optimize supply chains to ensure parts, fuel, and munitions arrive precisely when and where needed, minimizing waste. Autonomous transport systems reduce vulnerabilities along supply routes, while additive manufacturing enables production of certain components closer to the front lines, shortening repair times and enhancing resilience. While these advancements may lack the dramatic appeal of hypersonic missiles or stealth drones, their role in sustaining combat effectiveness and financial viability remains absolutely crucial and often underappreciated within defense planning circles. Although the initial development costs associated with these sophisticated systems are undeniably high, the long-term operational benefits they offer, such as significantly reduced personnel requirements, drastically fewer casualties on the battlefield, and substantially higher rates of mission success, gradually offset these upfront expenses, making them a prudent investment in modern warfare. Moreover, beyond direct battlefield advantages, their enhanced deterrence capability serves a vital strategic function by potentially preventing conflicts from erupting in the first place, thereby yielding savings and preserving resources that traditional defense budgets and accounting methods often struggle to quantify or fully appreciate. Looking ahead to the projected landscape of January 2026, these weapons and systems mark not an endpoint in military technology development, but rather a dynamic starting point, purpose-built to evolve continuously through seamless software updates, modular hardware upgrades, and integration with cutting-edge emerging technologies such as quantum sensing, advanced artificial intelligence, and expanding space-based assets. This ongoing evolution fosters a highly adaptable and resilient military force, capable of adjusting in real time to rapidly shifting operational environments, thereby offering a critical edge amid growing global unpredictability and complex multi-domain threat scenarios. The introduction of these advanced systems reflects deliberate strategic choices centered around maintaining peace, deterring potential adversaries, and ultimately prevailing in future conflicts by emphasizing attributes like speed, information superiority, and seamless integration, rather than relying solely on brute force or overwhelming firepower. Their deployment signals a profound shift in military doctrine, moving decisively toward prioritizing rapid innovation, flexibility, and adaptability, with software-defined architectures enabling continuous improvements and feature enhancements without the need to withdraw platforms from active service for extended periods. Additionally, by 2026, decision-making cycles compress dramatically due to the integration of sophisticated sensor networks and real-time data fusion, enabling commanders and operators to respond faster and more accurately as threats are detected almost instantaneously across multiple domains. This technological leap fundamentally reshapes what modern militaries can achieve, providing unprecedented situational awareness, faster tempo of operations, and improved coordination in an increasingly complex and contested strategic environment characterized by hybrid warfare, cyber challenges, and geopolitical volatility. In sum, these advancements collectively represent a transformative shift toward a smarter, more agile, and cost-effective defense posture that aligns with the realities of 21st century conflict and deterrence. Artificial intelligence evaluates options in real time, positioning strike assets to act swiftly before an adversary can respond, fundamentally changing warfare by exerting constant pressure and granting decisive initiative to friendly forces. This shift highlights the critical trust needed between humans and automated systems, as hesitation or delays can undermine advantages and alter outcomes, making seamless human-machine integration essential. Training and leadership evolve rapidly, emphasizing human-machine teaming, rapid decision cycles, and resilience under pressure to prepare forces for dynamic battlefields. Space assets have shifted from passive observers to active participants in targeting, navigation, and secure communications, significantly boosting operational effectiveness. Robust satellite constellations provide redundancy and resilience, preventing localized failures or attacks from degrading U.S. capabilities and ensuring continuous connectivity. Space-based sensors enhance situational awareness by detecting missile launches, tracking hypersonic threats, and providing real-time data fusion, offering commanders early warning and precise targeting. By January 2026, integration of space and terrestrial-based weapons enables seamless global coordination, reinforcing deterrence through swift, precise responses and allowing synchronized multi-domain operations. Maritime power shifts toward distributed lethality, spreading offensive power across smaller, agile platforms to complicate enemy targeting and increase fleet survivability. Unmanned surface and underwater vehicles extend fleet reach, gather intelligence, and reduce risks to sailors, while advanced missiles and directed energy weapons improve capabilities without larger ships. This distribution enhances survivability and flexibility in contested waters, reshaping naval strategy by early 2026 to better counter emerging threats. On land, future weapons redefine mobility and protection. Armored systems become lighter, faster, and digitally integrated for rapid deployment and coordination with air and space assets, enabling networked warfare. Active protection systems intercept threats pre-impact using advanced sensors and countermeasures, while enhanced battlefield awareness supports quicker, smarter decisions. Infantry increasingly employs robotic systems for resupply, reconnaissance, and casualty evacuation, boosting combat effectiveness and reducing physical strain on soldiers, improving endurance and operational tempo. The force achieves rapid maneuver, intelligent engagement, and sustained operations amid electronic warfare and contested communications. Air power evolves as manned aircraft operate alongside loyal wingman drones that extend sensor coverage, carry weapons, and absorb risk, increasing flexibility and allowing pilots to focus on strategic decisions. Hypersonic strike capabilities enable rapid, precise attacks on high-value targets, and by January 2026 are fully integrated, offering commanders unprecedented options for shaping the battle space. Collectively, these weapons strengthen deterrence by ensuring potential adversaries know the U.S. can detect aggression early, respond decisively, and adapt faster than any opponent, reducing miscalculation risk and enhancing strategic stability across all domains. Advanced weapons systems challenge U.S. dominance as adversaries develop asymmetric tactics to counter technological advantages, maintaining dynamic competition despite deterrence efforts. These evolving threats require continual reassessment of offensive and defensive capabilities to keep a decisive edge. Ethical and legal frameworks guide deployment, emphasizing responsible use, transparency with allies, and adherence to international laws to uphold legitimacy. Autonomous systems include human oversight and clear engagement rules to ensure accountability and prevent unintended consequences, preserving moral authority and public trust. These principles shape system design, operational doctrines, and military decisions. Collaboration among government, military, academia, industry, and the public is vital to address ethical concerns, risks, and societal impacts of emerging technologies. The defense industrial base adapts through strengthened partnerships that accelerate innovation while ensuring quality control, cybersecurity, and supply chain integrity. Resilient supply chains utilize advanced manufacturing, diversified sourcing, and strategic stockpiling to counter disruptions. Allied interoperability improves effectiveness through data sharing and joint training, requiring investment in compatible technology and infrastructure, reinforcing security ties and global defense priorities. By January 2026, many advanced technologies will be fully operational, offering speed, integration, resilience, and adaptability, key to deterring aggression by making hostile actions futile and costly. Their intelligent capabilities enable rapid evolution beyond adversaries, setting new standards and reshaping global security, geopolitics, defense planning, and the balance of power as 2026 marks a transformative period in military history.